from the very beginning, which occurred many years ago, to enterprise KPI and performance. So the very few years ago, maybe at least 4 years ago, I discovered on Twitter storytelling about Game of Thrones. The TV show was everywhere. People were talking about Game of Thrones at the coffee pause. And I discovered this really amazing data storytelling. And I really wanted to achieve this kind of things. I was really wondered, and I wanted to be able to produce that kind of things just for fun. So in New Caledonia, there is a comic book, and I decided to implement it the same way Game of Thrones and see what could happen. So it's a paper book. So I had to modelize the data. I took inspiration from the Game of Thrones storytelling, started to modelize characters and interaction between characters. Then I had to collect data, which was a manual process, switching pages and putting the data in my fingers on my laptop. Then prepare the data in CSV, actually. Then starting to perform some analysis. Then produce storytelling, discovering models. And while pushing some analysis, at this time on Gephi, I started to see emerge like kind of intelligence. In fact, this time it was about sociology. And this is a very important part in this adventure because it led to a lot of other researches. To make short, here the data says that kids talk between kids on the bottom on the left, and on the right side there only are adults. So that was my very first discovery, and I wanted to perform some other kind of discoveries because I really enjoyed the feelings. 3 years ago, when I came at OPT New Caledonia, I'm in a division where we have a lot of data coming from a lot of places, a lot of applications, a lot of workflows interacting each others. And some people in my division started to draw with a mark on paper this kind of drawings you see on the right. It's the original one, in fact. And people were coming in the office and asking us, would you know which connects to this and do that? And I decided to pay great attention to this kind of drawing and even perform some experimentations, which were taking back the paper and see what people were doing. And people did strange things. They started to ask, where is my paper? Who took my paper? I want it back. So that was very interesting as a manager. And I started the following workflow, which is still in use today. I started to use my team activities, then started to implement visual management, which is a key part in graph databases, then starting to challenge with question. Not only once why, but why, and finally you get the final answer. You get the real problem you have to solve. Then when you have a quite important amount of questions, you have to sort them and score them. The most important one or the easiest one, you have to achieve this kind of management task, which can be led with the Lean method or Agile Scrum methods. And then when you answer this question, you have this catalog of questions, you see new opportunities coming to you at a very fast pace and not necessarily at a very high cost. So here is the framework I use on a daily basis. First thing, we deliver software very fast and the right thing. So if we fail fast, with not a lot of loss of money nor time. Then we produce as a team. It's very important, even with people with remote working, we produce as a team and we use the right tool for that. Then, as developers, as software developers, we make a version of everything. We can go back in the past at any date we want. And then we deliver. We deliver at a very fast pace, very often, and we check the quality and we challenge how people react to what we are delivering. We answer questions. We are here to answer questions. And then, this is a bit more the management part. You observe new habits. Because when people have new tools or new answers to their traditional questions, they change their habits. and you have to take great care of that. Then, if you are a lucky guy, you can see appropriation, which means you are on this track to success. People use your tool and sometimes use your tool to make something else that you initially thought about. This is a great indicator of you are on the success. And deliver value at a regular pace, which means we don't stay a month without delivering something. We deliver value on little increments, weekly or sometimes daily. And finally, this is the holy grail. You impact the culture. This is really what you must achieve if you want to perform with many people. So there is a little question for you. So I'm going to launch it now. According to you, which KPI drive your IT services? So if you go on menti.com and put your code, you should see which KPI are coming up. If you can go to it. I don't know if you can use it. I don't see people coming. I'm going to copy the link in the chat. Here we go. Oh, maybe the technical issue. So maybe you could think about financial, people, where do you live, these kind of things. And so I skip to our tools, our stack, like we say in software development. First, we use paper and markers. For visual management, it's the best tools. Everyone can get this kind of tools. Then we use GitHub, github.com, to store the data, to make issues, to store our code and our data. Then comes Neo4j, then Bloom, NeoDash, and then more technical, Docker, Cypher, Python, Jupyter Notebooks, and GFI. Ah, yes, the first results are coming. Excellent. So this is actually very interesting. So I see coming on the first KPI, human, money, time, security, return on investment, and time. This is really an awesome feedback, and we'll see later. Time, yes, financial, achieved goals, ticket resolution time. Oh, it looks good. New versus closed tickets, yes. This is all about performances. People, human are coming twice. This is really exciting. The main philosophy of my speech is that we have to see the enterprise as a whole thing. And that, like in nature, the whole is greater than the sum of its parts. And it's like a mantra, an everyday mantra, which help keep us on the track. If you have things in pieces, you will lose performances, you will lose money, you won't be able to deliver the solutions you want to deliver at the right pace. So here's like a Maslow pyramid, made by my one. So first, like a lot of you have already said in the Menti, there is a money. Without money, you can't have people working for you. This is why people and skills come just after the money. If you have people with no money, they won't work for you except on open source, but you won't necessarily be able to achieve the goals you have to achieve. Then once you have money and people, you can develop your own services, which mean website, applications, mobile apps, that kind of things. We are software engineering, and then we are coding a lot of things every day faster, and then we generate technical debt, which means it works one day, but 2 years later, the look and feel is not the right one. We have security flow eventually, and that kind of things. And then we come to the next step, the build and run. The build and run, for those who don't know what it is, when you build things, everyone loves to build things. I create something, I'm very happy with my new toy, but then 1 year later, it can become a real hassle to maintain it up and running and secured. And then we achieve the top of the pyramid, which is the time to market. When you have an idea, you want it to get it on the next week, on the next month, and also next year, because if you deliver on the next year, other people will have made instead of you, and you have lost. And then you are lack of money, then you will lose people, you won't be able to run your services, and this is a very bad trip. So this is a holism. And the holism relies in IT management on a lot of data. We are data-centric, we are data-driven. So here on where we get all our data, I will show you in the next slide. First, our assets are applications. Applications are web services, mobile apps, software as a service, everything we rely on to manage our activities. Then, as another service, we have github.com. I mean the API, because GitHub gives a lot of API to see what kind of code are we doing, how many people push code, when, which kind of quality, that kind of stack. How we using Java, Python, this kind of things are provided by API. We can do the same kind of things on GitLab, which we are doing. Then we can use SonarQube for software quality. And you can see we have actually a lot of API of data sources, like sometimes end of life, because each piece of software has an end of life, and you have to manage it. You have to monitor it if you don't want to have problems. Also, we have some enterprise resources like Active Directory, which is linked to people. You want to know who is working for you. Also, skills and missions. Where are your skills? Where are the competencies? Do you have the right people at the right place? And also, you can integrate with a lot of third-party services like open data, localities, geographical information systems, financial services on Oracle, for example, or even scrap documents on SharePoint. There are other kind of data, but this is what we can work on. Then the next step is to map all the organization as the whole thing, as a whole living thing, driven by the data itself. So here is how we can browse the data model of enterprises. This is graphical. And you can see that how things are interacting the one with the others. Then you can see that later you can drill down, see how people are connected to financial services, how technical debt can be managed, and that kind of things. As a manager, when you see that kind of things, I can tell you that it's a very exciting experience, because you feel that finally you master your data. Then you can rely on Graph Data Science, which is embedded. I won't make a full tutorial on which metrics we can rely on, but mainly you will see how we use centrality, for example, and connectivity and that kind of things with visual management. Here we go. Our first topic is application centrality. So as you can see, there is an application in the center, and what the recurrent question we have: if I fail this, if I have issues on this application, which other application will fall? This is a crucial question, and we have to be answered to answer it very fast and very, very, very efficiently. That was our first MVP on this modelization. Now it's time for the second test. I'll send you the Menti. Here we go. Let's go. So you have to sort application criticality by domain. So is it the money? Are there the people? Is it geographic information system or document management, like invoices, that kind of things? or the fact to know your customer. So once you get some data, some IDs, and once you have finished your ranking, we'll see if the data is matching your expectations. I make a little solution to keep in time, to keep in track. So first, oh, very interesting. Financial is coming first, then the customers, then human resources. Oh, human resource is coming second, then customer, then document. Very interesting. So this is what you imagine. And what you see right now on the presentation is what we got out of the data we currently have. So this is based on the calculus of centrality on an algorithm called PageRank. And the first kind of software which is coming first is money, is a financial capital, because without financial capital, you can't do anything, but this is told by the data itself. Then you have a second kind of capital, which you have ranked third, but which comes second in our data. It's a social capital, it's the people, it's the skills, that kind of things. And then the surprise came that for the third position came the GIS. And for telecommunication and postal services, finally it makes sense. Then come customer and prospects, which are linked to financial capital, then document management. This is very exciting and very satisfying to see that you can modelize and that the data bring you some kind of truth. Then often in presentation, in some meetings, people make a lot of video and you have picture. But in information services, what you want is data. So a drawing is good, but our job is to provide data. So this is how we achieved our modelization. And on the right side, you have a cloud environment running on Azure with Power Apps and that kind of things. And on the left side, on the yellow, it's the on-premise. Items on the right side on blue are blue because we have an attribute telling that it's a SaaS services. And what we can say with data is that you have a single point of failure here. You have to pay great attention to this link, because if you lose it, you lose all the right part of the application, and then you have a loss of services. So it means you have to put efforts in putting high availability services on this side, driven by the data. This is what is really exciting. Then I also talk to you about people, skills, mission, activities. So what we have achieved is that we could import through API calls referential of skills, which is called CGraph in France, is dedicated to information services skills. And we could import them on our model. So here I am. I know that I am managed by some people, but for each people of my team, I also see which skills they have. So you have a cartography and also a family of skills. For example, here I see that we have a lot of skills around project management. So I can make decision. I can ask for more resources, for example, to manage project, or more resources for software developer if I need to go faster. Then we can use what we call topology. Topology is a mathematical concept, which is in fact the science, the study of the space. But here, very simply, what we can see on the left is that topology, which is an abstract concept, becomes a really important, very important KPI. On the left side, you can see that you have two kinds of knowledges. You have two graphs that are disconnected. This is a lack of knowledge. Clearly, you have two systems, and you cannot connect them. So you lose information. This is not holism. On the right side, this is what we could achieve after some work on scrapping new kind of data, and then we could build a bridge between these two graphs. And then it means that we can generate more intelligence, more knowledge on each kind of node of the enterprise, from people to assets, to money, to everything you want to know. You can discover a lot of very exciting things and put some KPI. For example, for those who know DevOps, DevOps is how operational sysadmins, DBAs, are collaborating with software developers. And here, thanks to the data we've pulled from GitHub API, you can see that there are some codes exchanged between two kinds of teams. This is all generated by data. In fact, this is sysadmins here and their repos all around. This is software developers and their repos. And you can see that some people have made contribution each other. So these two nodes is not that bad. We can make DevOps between these two entities, but not with this one. Why is that? Should we improve that? Is it a risk? You have to make choices, and with that, you can perform this kind of analysis. And if someone tells you in your organization, are you doing DevOps? You can yes, but I have two islands, two disconnected graphs. Centrality of applications. Sometimes you can see that you have clusters of domain-driven clusters of applications, and sometimes you have an application which is between these two domains. So this means you have to put a lot of efforts to make this availability as big as possible. Then put maintenance resources and a lot of people to make sure this stays up as much as possible. As told earlier, when you develop things also, it's like your car, you have to make some maintenance. And we could inject some data about software end of life, which means past a certain date, you have to change your software because if you have a security flaw, it won't be fixed. So you are in danger potentially. So we could create this NeoDash dashboard. We can make available at a single place all the technical depths KPIs. So you can share it with other teams and be able to invest on the right place. Sometimes technical depth may be acceptable in some places. Maybe JavaScript is not so bad, but in some other places, you have to fix Angular because it's end of life and it won't be secured, or it won't be able to offer an optimal experience, user experience. So very easily, as we can get the whole thing, you can attach technical depth to financials. So this is really exciting. And even you can find path between technical depth and financial cost. For example, do application with the maximum technical depth imply maximal cost? Where should you invest your money to avoid that kind of anti-patterns? And as you can see, it's as a service. You can see all metadata occurring when you drag a node, and it's very comfortable. You don't have to to produce documentations, as it's very easy to use. So this is a little focus. So it's all Cypher driven. So here you have the query. You have a radar chart here from NeoDash. And you can browse interactively. Also, it's very comfortable in technical depth and apps. So you can detect some kind of segmentation by domain, by stack, and that kind of thing. For software engineers, it's very comfortable. As told before, you have to be able to link applications to financial cost. This has been achieved. Here on the node, you can see the application, which has here a GitLab repository. So here is the source code. And you have a Node.js node. So you can see if you have technical depth. You can see who maintains your application. Eventually, you can also have a repository on GitHub. And this is the financial part. So this means the application, you have money to maintain this application. And how much did it cost to you? Each time you have nodes that tell you how much money you have put in. This is very easy to interact with, and the query as a model is very easy to use. Cypher queries are also very easy to design. So sometimes we change the paradigm and there are new metaphors coming out. So first, the questions are repackaged as data storytelling, which means when you have a large question, you will create a storytelling with maybe dedicated dashboards. We use the Bloom perspective to answer a specific question because they are very easy to implement and deliver. Also, we deliver domain-driven dashboards, which means, for example, for banking services or postal services or for technical debt. Each question adds a kind of perspective. Also, our cartography is version itself. Everything is done on GitHub, so on Git, and we are implementing semantic release, so we can go back and forth and compare things in time. This is a whole story. We are working on this project since more than a year, and here's the movie of the code we have created with bots. Here we go. It's a bit lagging. Okay. So you can see on the top left that we have a lot of CSV. Then at a time, Python scripts are coming because we started to implement a lot of things with some markdown here. So you see growing the number of Python files and CSV files. You can see some Cypher coming and Jupyter notebooks also coming because the data scientist has joined our team recently. This is the whole story of our database. One of the most great achievements I could see as a manager was the rise of skills and cohesion. And the fun fact is that, in fact, you can score that because skills are part of the cartography itself. So we have a data engineering. We are using Kafka a lot, and we are using a lot of third-party API. We are performing integrations with the thanks of Python. We have now data scientists who make reporting, analysis, and give us feedbacks, for example, on model qualities. And we have developed also data storyteller skills on Jupyter, Bloom, a lot of Bloom, NeoDash, and a bit GraphXR. And now we are working on generating machine learning models to make links prediction, especially on technical debt and money. At the end, one of the biggest success is to see that we could, we could impact the culture as we could embed cartography right inside in documentation, like here in this example, Atlassian Confluence. I was not aware it was done, then I felt on that, so people are using it in real life without necessarily telling you they use it, which is awesome. What are the great questions, the biggest questions that matter? One of them is, how did application centrality evolve in time? Sometimes you have little third-party projects that appear, and 2 years later, it becomes very central and business critic. Thanks to Git and Neo4j, we can see how this application centrality is moving. At the beginning, it was peripheral, but then 2 years later, it's the center of the graph. So this is centrality. It's a very important metric. Then domain-driven clusters. I mean, is postal activities linked to telecom activities, for example? How do they? Let's find out. Also, relation between departments. Are people really collaborating code or not, or between applications? Is contribution between source codes linked to relation between applications? If not, maybe is it a risk? Maybe is it an anti-pattern? You have the data, you can make the choice, you can make the reporting. And some very easy metrics, very easy, but impacting ones. High availability fibers. I mean, if you have high availability applications and that you have apps apps that rely on it that are not high availability ones, you are at risk. So you have to make so every HA app rely on an HA app. Personal data fibers and GDPR. So it means you have somewhere an application that has a lot of personal data, and you have another application that connects to the application, but which says, no, I'm not using application personal data. Is it really true? If not, why is this connection? You should pay attention and look further what's with that. And then the holy grail also, money, prediction between technical debt and financial cost. I mean valuability. That's it. So the interesting part, the fun conclusion of that is that at first we are just here to answer questions to which am I connecting to. We are looking for answers at first, but now we are looking for the best questions, the best challenging questions. And that's my last slide. So if you have a question, you're welcome.
Awesome. Thanks. Thanks so much, Adrian. Well, we do have a couple of questions in the chat window. Let me just take them one by one. The first question is there any algorithm used in this project?
We used page ranking, eigenvectors, and also the one linked to topology with how detect linked nodes, the one with others. So basically, it's a GDS package, and also a lot of APAC too, because we needed to parse text and perform transformation and that kind of things.
All right. The next one is it flexible for large data if using a graph model?
Actually, yes. It's designed with, and we have started to use indexes, because when you create relations at a certain stage, you need to put indexes first to ensure that you have unique nodes, for example. And then when you create new relationships, it can take a lot of time to create the relations itself. But for that part, it's like on relational databases.
All right. And the next one is how do we access graph databases in C++ programs?
Oh, I guess there are a lot of SDK for Neo4j. We are using the Python binding, the Java binding also, it's very cool. I think there is a Go binding, I guess.
Yeah.
But the community is really active, so it's very well documented. And also you can perform REST queries or GraphQL, which we are not yet using, not yet.
All right. I think that's pretty much about it from the Q&A section on the chat window. Well, this was a really exciting session for me, at least. I'm sure it would have been same for the audience as well. Um Thank you so much, Adrian, once again. Thank you for your time, and look forward to having you for the next year as well.
Have a great end of day. Thank you.
Right. Thank you.
Bye.
Bye.